Hello everyone, this is Justina from Ceramic. In today's video, I would like to walk you through the process of connecting your Ceramic node to the mainnet. Before we dive in, let's have a very quick look at the available networks on Ceramic. In general, there are 4 networks available to you, and the choice of the network should be made based on what development stage your project is in. Mainnet, which creates timestamps on Ethereum mainnet network, is a public network that is best suited for the applications that are ready to go live and run in a production environment. Clay testnet is best suited for the early development of your application. It connects to the Ethereum Gnosis chain, allowing you to test your application in a safe testing environment. Devon Stable is somewhat similar to Clay testnet, but as the name suggests, it shouldn't be considered a stable network to build the applications on. It's best suited for running tests, trying out features, and doing some lightweight development work. And last but not least, in-memory network doesn't connect to any public Ethereum networks. It simply provides you with a lightweight environment to prototype, try out Ceramic features without writing any data on any public networks. So in this video, we are going to focus on how you can connect your Ceramic node to the mainnet. Let's dive in. In general, there are 3 different ways of how you can run a Ceramic node. One of them is running your node locally, and Ceramic comes with developer tools like Wheel that makes it easier to configure and run a local Ceramic node. And while technically you can run a Ceramic node that connects to the mainnet on your local machine, it's not really recommended because for production use cases, you'll want to run your node in the cloud environment. So that's the second option that you have. You can run your own Ceramic node in the cloud environment using a provider of your choice like AWS or Digital Ocean or others. And the third option is using hosted node providers. One of them is an ecosystem project called Higher Nodes, which basically handles all of the infrastructure hosting for you. But for the purpose of this video, I'm going to show you how you can run a Ceramic node on the cloud and connect it to the mainnet. To walk you through the process, I will be following this guide called Running in the Cloud that you can find on the Ceramic developer documentation. This guide walks you through the process of running the Ceramic node in the cloud environment, specifically Digital Ocean Kubernetes. But by default, if you follow this guide step by step, you will end up with a Ceramic node that connects to the Clay testnet. So what I will do is I will follow this guide and I will show you what modifications and configurations you have to do to run a Ceramic node in the cloud environment that connects to the mainnet. There are 3 things that I have already configured in my working environment. One of them is Kubernetes command line tool, kubectl. It's already configured for me and available for me to be used. The same applies to Digital Ocean command line tool, and I already have the API configured for this as well. If you want to follow this video, make sure to configure them as well. And this video guide here also covers exactly how you can configure the API for your Digital Ocean command line tool there. So make sure to check this out. And the third thing that I have configured in my local working environment is that I installed the ComposeDB CLI. I did that because we will need it at one of the steps. And if I type ComposeDB, you will see that I have already installed the ComposeDB CLI. So that is all that I have done, all of the pre-work. For the rest of this video, I will follow the guide that we have on the documentation and will show you what modifications you have to do to run a Ceramic node that connects to the mainnet. Okay, so the first thing is I need a Kubernetes cluster on DigitalOcean. I am going to create one by selecting Create, Kubernetes, and configuring only the data center region. I will choose one that is closer to me. I am based in Europe, so I will choose Amsterdam. but you can configure this option accordingly depending on where you are. And I will also decrease the number of nodes. I will set it to 1 because it's perfectly enough for this tutorial. And then I will hit create cluster. And creating the cluster will take probably a few minutes. You will see the progress bar here. And when it's all set up, this wheel will turn into a green dot. Now that the cluster is up and running, I am going to move to the next step and connect to my cluster on my local working environment. So I'm gonna copy the provided command and run it on my local machine. To deploy the ceramic node in the cloud environment, I am going to use the simple deploy repository, which contains necessary scripts to deploy and configure ceramic nodes in the cloud environment. So I am going to clone this repository. And enter this directory. Inside of this directory, you will find all of the necessary configurations used for configuring Docker images, also Kubernetes. We're going to dive into some of these scripts a little bit later in this tutorial. Now that I have the simple deploy repository ready for me to use, I will finish the Kubernetes configuration. The first thing that I have to do is I have to create the namespace called ceramic, because this is what Kubernetes will expect to see when deploying the ceramic node. So I will use the command kubectl create namespace ceramic. And when that is finished, I am going to generate the necessary secrets. More specifically, I will generate the admin did that will be used to grant me the permissions to run admin commands on my node. And I will generate the password for my Postgres database. This can be done by executing the script inside of the Kate's directory right here. Base compose db create secrets sh. So now we have the Postgres auth created and ceramic admin created. So now I am good to go and make the modifications in the simple deploy scripts. Inside of this directory, you will see that we have the Kate's directory that I referenced earlier. And here inside of base directory, I can find composedb. This directory contains all of the scripts and files that are used to configure and deploy the ceramic node in the cloud environment. Here I have 2 files that I will have to edit to make sure that my ceramic node connects to the mainnet. One of them is composedb.env, which contains all of the environmental variables. And another one is daemon config, which contains the configuration of the ceramic node that I will be deploying. So I will start with the composedb.env file. And here I will have to do a very small configuration, which is changing the ceramic network value. And by default, this value is set to clay testnet, meaning that this node, if I deployed it, would connect to the testnet, but instead I would like this node to connect to the mainnet. So I will change the value of this variable to the mainnet. And this is it. Now I can save this file and move on to the daemon configuration. Here I will be updating a few sections in this configuration file. But the first thing that I have to do is I have to generate the did for my node. This will be necessary so that I can authorize my node with Ceramic Anchor service. So at first I am going to generate a private key using the compose db CLI command compose db did generate private key, like so. And once I execute it, I am getting this private key that I can use to generate the node did. I will copy this private key and I will store it in the notes, just so that I have this key accessible to me when I continue with the configurations. So outside of the simple deploy directory, I have this simple file called notes, and I will just use it to take notes of all of the keys and dids that I am creating in this video. So our node private key will be this. And now I will use another command from the compose db CLI to generate the did key using this private key that we just generated. So compose db did from private key. Command will generate the did, and I just have to provide the actual private key here. And now I have the did key generated. So this did key will be set as my node did that I will use to authorize my node to connect to the Ceramic Anchor service. So node did will be this. Now, what I will be doing is I will be authenticating this did key for my node. And the first thing that I have to do is verify my email. And this can be done using a simple curl request. And the command for this looks as follows. We are going to send a request to the verification endpoint, and we are going to provide the data which contains the email. I will replace this placeholder email variable with the value of my actual email, which is justina@3box.io. And when I execute this command, I should get my email verified. So the response to this request was the message saying, please check your email for the verification code. So I will open my email and I will check for verification code there. Inside of the email, I have the secret verification code. It will expire in 30 minutes, meaning that I have 30 minutes to use it to authenticate my node did. I will copy this verification code and I will just save it here. And one of the last steps with did authentication that we have to do is we actually have to authorize the did. This can be achieved using the following request here, and we are going to send the request to the following URL, and we are going to provide the following data. So we are going to provide our email. So I will change it right away to my actual email, justina@3box.io. Then we are going to provide the one-time passcode that we got in our email, so the secret verification code. we have to provide the did. So we generated the node did here. I will copy the whole thing with the prefix did key. It's very important. And I'm just going to provide it here. And now I'm gonna run this whole request. And the response of this request says that the status, just a little bit difficult to see, that the status here is active. This means that our did, the node did, has been verified, and we are good to go and deploy our node. And this should be authorized for the Ceramic Anchor service. So now I will head back to the daemon config.json file and do a few of the final configurations before deploying the node. So here, one of the things that I will have to do is I will have to configure the auth method for the anchor. Since we generated the did for our node, we are going to opt for did authentication for anchoring. So I will simply add auth method, and I will set it to did. And one more simple configuration I will add to the node section of this file. And what I will do here is I will provide the private seed URL, which will be used to verify that this node is authenticated with Ceramic Anchor service. So I will provide the private seed URL. I will set it to the following value: in place ed 25519, which corresponds to one of the public key encryption algorithms. And after the hashtag, I will provide the private key that we created for the node. So the very first private key that we generated, I'm gonna copy it and provide here. And that's it. I will save this file. And now I'm good to go and deploy my Ceramic node. So for that, I'm going to use the kubectl command, and I'm gonna apply the deployments. And I would like to apply all of the changes that I have done to the composedb directory inside of the simple deploy. So I will do that by running the kubectl apply, and I will apply the changes in the directory. Kate's base composedb. And now we have all of the services created. And I can always check on the status of my pods and see if they are running. Maybe there are some errors, and I can do that by running the kubectl get pods. If I provide the watch flag, this will show me the status of the pods in real time as they are being updated. And if I specify the namespace Ceramic, we should be able to access the pods in the Ceramic namespace. So as you can see, the IPFS and Postgres are running already, and composedb is being initiated. And after a few seconds, I can see that the status of the composedb pod has changed to running, which indicates that our node is running successfully. And I would like to just double check that my node is indeed running on the mainnet. And I will do that by checking the logs of my ComposeDB pod. So I will stop the service and run the command kubecontrol logs follow. And I will specify the namespace as usual, ceramic. And I would like to access the logs of the ComposeDB pod. There is a lot of information that is specified here, but the key things that I wanted to check were that our node is actually running on the mainnet and that we are connected to the anchor service cast3boxlabs.com. And we also can see that the did key, the one that we generated, is set to be used as the node did. And I can check that by quickly checking my did here. And as you can see, it's the same one. So the authentication for the ceramic anchor service was successful. We are running on the mainnet, and now I can continue with my development and build my application that is running on the mainnet. So this is how you configure and run a ceramic node that runs in the cloud environment and connects to the mainnet. I will see you in the next videos, and happy building!